Today we're looking at notes AA-2, law of sines only given one angle. So before you were given two angles, but given one angle, this is called the ambiguous case because the other two angles could split up in a couple of ways. So solve the triangle given angle A equals 30 degrees, side A is 10 units, and side B is 5. Okay, so again, this might not be drawn to scale. You'll forgive me, right? So angle A is 30 degrees. Side A is 10 units. That kind of looks like 300 instead of 30 degrees. 30 degrees. Okay, and then side B that opposes angle B is 5 units. Okay, so that's what you're given. So now remember, we need angle B, we need angle C, and we need side C. Those are the three things we need to find. Okay, so first we are going to find angle B. So here's what we do have. We do have, and the reason we're going to find angle B first is because we have side B. So we're still going to use the law of sines. So remember that the law of sines says if you take side A, so 10, and put it over the sine of angle A, 30 degrees, that is equivalent to, okay, side B, which is 5, over sine of angle B, which in this case we don't know. All right, so we want to find angle B. So we are going to cross multiply like before. All right, so it is going to look like 10 sine B equals 5 sine 30 degrees. So then you can certainly divide by 10, and you still have sine angle B equals, we're going to plug this into the calculator, and again, I've already checked, the calculator is in degree mode. Okay, so I'm going to type in alpha y equals, enter 5 sine of 30 over 10, and we get 0.25 exactly, so I'm not rounding, 0.25 exactly. So of course, to get the B by itself, arc sine, or sine inverse, however you want to call it. So angle B equals to sine inverse of 0.25. So you are going to use the calculator to find this value. So second sine, which is sine inverse of 0.25, and this is what we get. So here's what I want you to think about. I want you to think about when we did sine inverse, what the calculator is giving you. So the calculator thinks the restriction, remember, for sine inverse is to the right side only. It's only giving you the right side. Let's talk about the unit circle. So for the unit circle, what the calculator gave us is this angle, and we're going to round just for sake of ease. The calculator gave us about 15 degrees. But there's also actually, because remember this means the angle whose y value is 0.25 on the unit circle. The angle whose y value is 0.25. So 0.25 is about a fourth, well it is exactly a fourth, of this unit circle, because remember this coordinate here is 0, 1. So and it occurs, the y value of 0.25 occurs at about 15 degrees. So it will also occur on this side of the unit circle, even though the calculator only gives us the one answer. Okay, and you have to think this is 180, so if you back up 15 degrees, what is this? This is 165 degrees. So what I want to point out is the calc only gives this answer. You must test this one. And we will come back to that, okay? We will come back to that. So let's finish off this. So remember, this is the ambiguous case. We're going to try and solve for one of the triangles and then see if we can also find another triangle that will work. So for now, we're just going to work with this angle. So we are going to use the exact value when we give our answer for angle B. Angle B is 14.478 degrees. Okay, that is angle B in this case. Remember, there's multiple scenarios. Okay, so now knowing that in this case, that's what angle B is, let's find angle C. So angle C comes from 180 degrees minus 30 degrees minus 14.478 degrees. And that equals 135.522 degrees. So you could type it in the calculator, that's fine. Okay, so that's finding angle C in this case. So now the last thing we have to find is side C. So we have angle B, which is about 15 degrees. We're going to plug that in there. Okay, we have side C, which is about 135 degrees. We're going to round. Okay. And then let's find side C. So we are going to use our law of sines, and we're going to take side A, because that was given, over sine of angle A, and that's going to be equal to side C over sine of angle C. We're going to use the rounded 135, the unrounded, excuse me, 0.522 degrees. So then of course you will cross multiply. All right, so 10 sine 135.522 degrees is equal to C sine 30 degrees. So then you will divide by sine 30, divide by sine 30. So when you plug that in the calculator, because of course those will cross, when you plug that in the calculator, you will get side C is 14.013 units long. Okay, so that's for one possibility. So I'm going to box this up. This is one possibility. Now we have to go through and test this other possibility. So let's test it. If 165 were an angle on our triangle, we have 165 degrees plus the given 30 degrees, and I want you to think about why that won't work, because that value there is already over greater than 180 degrees. Therefore, that's what the three dots mean, no second triangle exists. Okay, so this is the given angle, and this means therefore in math. It's used pretty frequently in proofs. Okay, it is not possible because if you think about it, a triangle adds up to 180, and with just these two angles it's already greater than 180. There's no way, because we wouldn't even have enough left over to make a third angle, so there's no way that that triangle exists. Okay, so let's try another example. So given angle C is 20.5 degrees, side C is 12, and side A is 31. So again, let's just draw a triangle here. I know it won't be to scale, but hopefully that's okay. All right, so A, B, and C. So we don't know A, we don't know B. We do know C is 20.5 degrees. Okay, we know side A is 31, and we know side C is 12. Okay, so what don't we know? We don't know angle A, we don't know angle B, and we don't know side B. So let's get busy. So find angle A. So using our law of sines, okay, we have C and side C, so 12 over sine 20.5 would equal, if we're wanting A, we'll want to use side A, so 31 over sine A. Of course, cross multiply, so 12 sine A equals 31 sine 20.5. Okay, I divide by 12, divide by 12. So sine A equals, when you plug this guy in the calculator, you get 0.905. Okay, and then angle A equals sine inverse of 0.905. All right. And then you get, when you plug in the calculator, you get 64.783. So I'm going to copy that down, 64.783 degrees. Okay, I'm not showing the calculator portion because I don't want to take up too much time here. So I want you to think about the unit circle. It's not the greatest unit circle. Think about the unit circle here, and think about where approximately 65 degrees would be. Okay, so maybe about there, 65 degrees. So that is saying the angle whose y value is about 0.905. That's so close to 0,1. Right? That's so close to the top. So, but we also have another angle who shares that y value, and it is on the other side of the unit circle here. So if you back up from 180, 65 degrees, what's that angle? That angle is 115 degrees. So we will deal with that one in a minute. Let's talk about this one now. So we found angle A. All right, so now let's find angle B. So we have 180 degrees total for a triangle minus 20.5 degrees minus the 64.783 degrees. And that brings us over here, when you plug that in the calculator, to 94.717 degrees. Okay, so now I've found angle B. So now, last but not least, find side B. Okay, so we have given to us 12 over sine of 20.5 is equal to side B, which is going to be, we don't know, side B, over angle B, which is sine of 94.717 degrees. Oops, don't want to forget my degrees there. This one too, forgot my degree. All right, so then you're going to cross multiply. So 12 times, oh, I forgot my degree there. 12 times sine 94.717 degrees equals B times sine of 20.5 degrees. So then you're going to divide by sine of 20.5 degrees. You're going to plug this in the calculator, and you're going to get side B is equal to approximately 34.149. Okay, so now that we've got one triangle, let's talk about the possibility of a second triangle. So could 115 work? All right, so 115 degrees plus this possible angle plus the given 20.5 degrees is well under 180 degrees. So therefore we have a second triangle. So therefore second triangle exists. So cool. All right, so now then, knowing that, let's come over here and start solving. So for the second triangle we call this angle A2, and then angle B2, and then side B2. Okay, so let's find angle A2. So we have 180 degrees, not because of the triangle, but because this right here is 180 degrees, and back it up, not 65, that was just our use of here to guesstimate. Use the pure angle, minus 64.783 degrees. So make sure you use angle A and pure, not our estimate, not our rounded. So then that's going to give us 115.217 degrees. Okay, and then to find angle B2, of course you'll take 180 degrees minus 20.5 minus 115.217 degrees, and you will get 44.283 degrees. And then last but not least, finding B2. So that's going to come from 12 over sine 20.5, so that was the given, is equal to B2 over sine of 44.283 degrees. And then we're going to cross multiply. And we're going to have 12 sine of 44.283 degrees is equal to B2 times sine of 20.5 degrees. Then we're going to divide by sine of 20.5 degrees. 20. And then you're going to get in the calculator, after typing all of this in, you're going to get B2 equals 23.924 units long. So to draw a picture of this triangle, since we had the other one over here, remember C is given, it's 20.5 degrees. And then A is here, B is here. A we found out to be about 115 degrees. So remember, that's why this one worked, because this angle and this angle didn't add up to over 180. We had enough degrees left to give us that third angle, where in the previous example, it was already above 180, so that was not possible.